In a previous demo, we showed how to calculate risk levels based on a device's operating system version. Risk levels are used by AppGate's policy engine to grant or deny access to applications, data, and other business-critical resources. This demo will build upon the earlier example to address a scenario where an organization wants to secure access to two different applications. The first is a knowledge base application used by employees. The second application is for expense reporting. It is used by both employees and external contractors. This organization instituted a policy that requires all devices have a recent operating system. For their purposes, recent means the current version or no more than 2 versions behind. Check out the previous demo video to see how we set that up. So access to the knowledge base application will depend on the following: that the user is an employee and their device is running a recent operating system. Applications that are more security sensitive, like the expense reporting app, will also require confirmation that the end user device is not compromised. In this scenario, the SDP administrator must get this information from 2 different systems: CrowdStrike for the employee devices and Envision for the contractor devices. Access to the expense reporting app will therefore have to follow these rules. If the user is a contractor, they must be using a device that has a recent operating system and a low Envision risk level. Or, if the user is an employee, they must be using a device with a recent operating system and a low CrowdStrike risk level. So in this demo, we're going to show how the Risk Engine service makes it easy to integrate with third-party services to generate risk levels. It'll then show how those risk levels are used in entitlement conditions to allow or block access. For the curious, here's a high-level diagram of the demo setup. Now let's get to it. We'll begin by accessing the AppGate ZTP Cloud Console and go over to the Risk Engine. We'll create our next Risk Engine rule. This one will check CrowdStrike ZTA to get the trust score for the device that's trying to connect. Like all adapters, this one has a default risk rule mapping. So this will essentially invert the trust score. Because our Risk Engine generates risk levels, we need to take the trust score and invert that. So we'll just accept the default mapping here. And then we'll create our next risk rule, and that will gather the data from Trellix Envision. This adapter is looking for detections and events on an end user's device. And we'll use that information to map to a risk level. So I've just accepted the default mapping as before, and now we go over to the SDP console, and we're going to add these 2 new risk rules to our condition. And you can see that this is the complex condition. It's used to check to see which type of user is connecting. Is it one of the employees? Is it one of the contractors? And then based off of that status, it then compares the risk level from the third party as well as the minimum OS risk level. So this single condition is able to do quite a lot for us. And we're able to now apply that to policies and entitlements as we need. And here I'm just going to add it to the entitlement for the expense reporting system. And when we put that in action, you can see that my sample user, he was unable to access the expense reporting system. And as a SDP admin, I can easily go in and identify why. And that's because the operating system on this device was too old and had too high a risk. So that user got blocked. This is good information now for the SDP admin to tell the end user so they'll upgrade their system.